So what's considered the basic trigonometric identities, a few of them are, so the first one, let's look at that we know that sine of theta is opposite over hypotenuse, and cosine of theta is adjacent over hypotenuse. And let's kind of combine that with the fact that we know that tangent is opposite over adjacent. So what I can do, what I'm going to do right here, is what if I change this, instead of just opposite over adjacent, if I divided both sides, top and bottom, not sides, but divide top and bottom by hypotenuse. Then I'm going to have opposite over hypotenuse over adjacent over hypotenuse. Okay. Well, opposite over hypotenuse is sine of theta, and adjacent over hypotenuse on the bottom is cosine of theta. So tangent of theta is equal to sine over cosine, sine theta over cosine theta. And as you can imagine, if you take the reciprocal of tangent is cotangent, and the reciprocal of sine over cosine, the sine over cosine is going to be cosine over sine. So these are two identities that are very helpful for a lot of things, so they'll come up. So this is why. And then another one of the ones that is considered basic deals with negatives. So these are called the negative angle identities. Negative angle identities. So for sine of theta, let's compare this to what sine of negative theta would be. So if I'm going to kind of sketch a quadrant. So whatever sine of theta is, remember these are the y values on the unit circle, or let's put down the unit circle. So let's say a theta is right here. So what the y value is would be this. So this y value. So if I went to, instead of positive theta right here, if I went negative in the negative direction, what would y be? It'd be the same value, but it would be negative. So sine of negative theta, like I have right here, sine of negative theta, it's going to be the opposite of whatever sine of theta is. So usually it's given as like this. Negative sine of theta is equal to sine of negative theta. Let's do an example. How about if sine, you could write it underneath. I'm going to keep it like this example to the right. If sine of theta equals a half, find sine of negative theta. Find sine of negative theta. We usually show this in parentheses. So whatever the angle is, I mean, I could figure it out, but let's pretend I don't know what it is. If I have sine of theta is a half, so let's draw the unit circle, add a half, I'd be right here. So then here's theta, so that means whatever the negative theta is, it's still going to be a y value of a half, but negative now. So negative 1/2. And to kind of prove that, do sine inverse, the angle actually is 30 degrees. So then now punch in sine of negative 30 degrees, and you should get negative a half. So negative 1/2. So that's sine. Cosine, for cosine, so let's compare cosine of theta and cosine of negative theta. Again, I'm going to show it on the unit circle. And again, I'm just showing it in quadrant 1, but it's going to work the same depending on any quadrant you start off in. So let's say right here, this is theta. Theta right here. So remember, cosine, this has to do with the x values on the unit circle. So whatever this x value is. So if I have a negative theta, if instead I'm going this way, negative theta, and right here, notice it's going to be the same x value. It's going to be the same sign. So these are equal. Okay, so let's check out, how about cosine of 45 degrees? This is root 2 over 2. If you put in your calculator, it's going to say 0.707. If you did cosine of negative 45 degrees, right now I'm down here. This is x value is also going to be a positive root 2 over 2. Okay. So cosine of theta is equal to cosine of negative theta. And then last for tangent. Tangent of theta compared to tangent of negative theta. Let's see what's going to make this true. Okay, so we've got our theta versus our negative theta. And which way we're going. So tangent, remember tangent is y over x. So here, if it was a positive, I'm going to have a positive over a positive. But if I go the negative direction, I'm going to have a y would be negative, x would be positive. So that means whatever the value for the positive is, the negative is going to be equal value, but switch sign. So negative tangent of theta equals tangent of negative theta.